Hey everyone, we're going to take a look at building a RESTful API using Node.js, Hapi framework, and Couchbase as our NoSQL database. If you've been keeping up with my videos, you'll know that I recently did a video on Node.js and Hapi framework, but that example used mock data and did not include a database. This time around, we're going to be including a database. We're going to explore everything that we had already explored in the previous example and do some real life scenarios that is ultimately, in my opinion, very cool stuff. So I do have Couchbase installed on a machine somewhere on my network. I am logged into it, as you can see through my web browser, and I did have a terminal up for our new project. So we're going to start by creating a new project, and then we're going to work our way into things as far as creating Couchbase credentials, installing the SDKs, things like that. But ultimately, it should be pretty easy to follow. And we can accomplish some pretty powerful stuff. So first of all, in our terminal, or just by hand, or however you want to do it, let's go ahead and create a project somewhere on our computer. So I'm going to say make directory Couchbase Hapi. So that's going to be my project name. I'm going to navigate into that project, and I'm going to say npm init-y. So what that does is it goes ahead and it creates a package.json file in that project directory. We're going to be doing all of our code inside of a particular file. You could really name this file whatever you want. Our file is going to be called app.js, so we're going to say touch app.js, and it can be created however you want, again, just like the directory. The next step here is we're going to install some project dependencies. So the first dependency, we're going to say npm install. We're going to say nodemon --save -dev. So this is a development dependency and not a project dependency. So nodemon is actually a tool that will watch your project and restart your server or your application in general every time it detects a change. And that's valuable because it prevents us from having to stop and start our project repetitively. With that development dependency installed, let's go ahead and add our project dependencies. So we're going to say npm install, we're going to say hapi, and we're going to say Couchbase. I'm going to say --save without the dev postfix. So that installed Hapi framework, and it installed the Couchbase SDK for Node. Before we jump into our project as far as a code, we're going to go into our database because we have to configure a few things. First of all, we have to make sure that we have a bucket available for our project. As of right now, I have no buckets, so we're going to create a bucket. Let's go ahead and call this example, and we're going to give it a RAM quota. So this RAM quota, let's go ahead and give it 256 megabytes, and let's use a Couchbase bucket which has in-memory as well as persistent disk, whereas the other two are just strictly in memory. We're going to add our bucket. Should create it in just a second. It's created. It has no data in it, which is fine. The next thing that we want to do is we want to go to security, and we want to add a user that has access to this particular bucket. So we're going to create this user. We're going to call it demo. We'll give it a password. I'm just going to use very simple 1 2 3 4 5 6, and I noticed that I just entered it into the wrong field. Let's just call it demo user. Paste that password in, and we're going to give it some roles. So for this particular project, we're going to give it some data roles, which will give us permission to read and write data using key value operations. So we're going to give it the data reader and the data writer. I don't recommend doing a wildcard because that can cause problems as far as security goes on your application, but that's ultimately up to you. We're also going to add query roles. So we're going to say we're going to add delete, we're going to add insert, we're going to say select, and we're going to use update. We won't use all of them, but the idea here is that we want to have full privilege to execute nickel queries, which are SQL queries for JSON, against our database from our Node application. And we'll hit save. So you'll notice that those roles have been created for our demo user. The next step, as far as configuring Couchbase, is we need to go and add an index because we will be using nickel. We will be querying based on index properties, we need to create an index which doesn't exist. So if we go to query, let's go ahead and wipe out what I have in my editor already. We're going to create an index, and we're going to say create primary index on, and we're going to say we named it example, right? So we're going to execute it, example being our bucket. It worked successfully, and at this point we have a fully indexed bucket. Now in a production scenario, you probably want to be more specific with your indexes and index based on certain properties. This, for prototyping purposes and for this example, a primary index will get the job done, although it won't be very fast, which is fine for this example. So at this point, we should be able to go into our code and start developing, because if we go to our buckets and we click on documents, we don't have any documents as of now. So let's go into our project, and let's go ahead and open it using our editor of choice. My preference is Atom, but you can use whatever you want to edit with. So when the project opens, the first thing we should probably do is we should probably hook up NodeMon to make our lives a little easier. So inside of the package.json file, in the scripts area, let's go ahead and add a script. Let's call it start. And let's give it a path. So we're going to give it our local path, NodeMon, not NodeMon, Node modules, NodeMon/bin/nodemon.js, and then app.js. So this is inside the local node modules directory, and we're going to say when we run start, it's going to watch our app.js file. Pretty simple. We can close that out, go into our app.js file, and we can start importing our dependencies. So we can say something like const, we can say Couchbase, we can say require Couchbase. We're going to say const hapi equals require hapi. And for now, we'll just leave it at that. And we'll be adding dependencies as we go along. But just to get us started, this should be sufficient. So let's go ahead and set up our hapi server. So we're going to say constant server equals new hapi.server. And we're going to configure that server. So server.connection. And we're going to say the host is going to be localhost, and the port is going to be 3000. Now you can add some more complex stuff into the connection configuration, but for this example, that's perfectly acceptable. After we've defined our connection, we can say server.start. We're going to look for errors. If there's an error, we're going to say if error, then we're going to say throw error. Otherwise, we're going to print out console.log. We're going to say listening at server.info.uri. And what that's going to do is it's going to print out localhost and then port 3000. So if we wanted to, we could run this, and we're going to do that and follow along. So we're going to open up our terminal again, and we're going to say npm start. And you can see it says listening at localhost 3000. So we don't have any endpoints set up, and we don't have Couchbase set up. So like we saw in the previous video that I made, if you watched it, we'd just get a 404 error if we tried to hit this address. So what we want to do is we want to configure Couchbase, our NoSQL database, to be a part of our Node application. So somewhere at the top, let's go ahead and connect to Couchbase. So we're going to say constant. We're going to say cluster equals new Couchbase.cluster, and we're going to provide it a host where our cluster is running at. So let's go ahead and say Couchbase, and it's running at 168.192.1.15, I believe, on my network. So we're going to try that. If we run into problems, we'll fix it as necessary. We have our cluster connection, so now we need to open up a particular bucket as part of our connection. So we need to say constant bucket equals cluster.openBucket, and we called it example. Now this isn't going to work out of the box because we do have a user account. We do need to authenticate our user, so that way we have permission to create data or query. So we need to say cluster.authenticate, and we need to say our username was demo, and our password was, I believe it was just that. Something simple for this example. And save it. All right. One more thing as far as getting Couchbase kind of up and rolling here. Let's go ahead and say const. And let's go ahead and say nickel query equals Couchbase dot nickel query. And it's not absolutely necessary that we did that. It's just a shortcut way because we will be using nickel query. It's kind of a pain to have to do Couchbase dot nickel query every time. So it does kind of make things a little easier for us. So we do have everything wired up and ready to go. One thing that we may want to do just for safekeeping here is watch for errors on our bucket, just in case things come up as far as permissions or anything else. We can say bucket.on. We can say on error. And then if there's an error, what are we going to do? So we're going to say console.directory, or I think it's directory, but basically it's going to print out our object for us. And then we want to say process.exit with a status code of 1 saying that there was an error. Perfect. So if we go to our terminal now, let's make sure everything's fine. So far, client-side timeout exceeded. Let's investigate that real quick. So I have a feeling it's because I probably typed in the wrong host here is why it's not working. So if I look at my web browser here, I notice that it's 192.168. So I actually have things flip-flopped. So let's go ahead and give it a try. So let's do 192.168. Let's save it. Let's look at our terminal here. So far, everything looks good. And the reason why it printed out that error and stopped, well, because we caught that bucket error. If we didn't have that, we probably would be flying blind as far as what's going on, why we can't access our data. So it's a good thing that we had that listener on that bucket. So the next thing that we want to do, now that we have connected to Couchbase, is, well, maybe we want to create our first endpoint. So let's go ahead and create an endpoint. We have no data in our database, so the most logical step would be to, well, create data. So let's go ahead and say server.route. Let's say that the method for this route is going to be a post method. The path for this route is going to be a person. And the handler for this route is going to do the following: request, response. What we're going to do is we're going to do a create operation, so an insert operation using a key. So what we want to do in a lot of cases, but it's not the only case, is, well, let's create a unique key for each of our documents. And to do that, we can create a UUID using the UUID package. So let's go ahead and stop running our application. And let's say npm install UUID. But to follow up on this, there will be one more package that we'll be using in this example. It's called Joy. I used it in my previous API example video. It's for our data validation. So let's save both of these. And let's rerun our application. So if we scroll back up to the top of our application, let's go ahead and say constant UUID equals require. And let's say UUID. Let's say constant joy equals require joy. All right. So inside of our person route, let's go ahead and save that first person. So first of all, we're going to be sending a payload. We're going to be sending a JSON body with this post request. And we're going to want to validate that that JSON body is correct. So let's go ahead and add our validator. So we're going to say config. This is going to be an object. Let's add a comma there so I don't get an error. We're going to say validate. And we're going to say payload. So this is exactly what we would expect in our JSON object that we passed through. So we're going to be expecting, let's say, a first name. This is going to be joy string, so we're expecting a string, and we're expecting that it's required. We're not going to specify a length or anything like that. We're going to have a last name, joy.string.required. And we're going to have two properties that are essentially forbidden properties. So we're going to say, first of all, we're going to have a type. So this is going to be joy string forbidden. So we don't want the user to be able to enter this value. And then we're going to default it to person. So this is going to represent a person type of document. We're also going to have a timestamp, joy.string, let's say any actually, dot forbidden, dot default, I'm going to say new date, dot get time. So it's a very simple NoSQL document that we're creating, but you're going to see where it becomes valuable in the next steps. So we're validating that data. Now we want to insert it. Well, actually, let's go ahead and say we also want a forbidden property of ID. We won't have an ID. Let's leave that out. So let's go ahead and say bucket dot insert. We're going to say UUID dot v4, and that's going to be our key. And we're going to say our storage is going to be request dot payload. And then upon success, we're going to say error or result. So if there was an error, we're going to say if error, we're going to say return response. We're going to say code. It's going to be error.code. And we're going to say message is error.message. And we're going to give it a response of 500, saying that it was a server error. And the reason why we're not just passing the error object into this response is because some of these are hidden properties. So for example, message won't appear in the response, which can be kind of maddening. It could be very annoying because you don't really know what the error is. So that's why we're specifying it. So if it was successful, we can say return. And we don't have to say return. We can just say response result. So let's go ahead and give that a try, see what happens. So we're going to go to Postman. That's how we're going to be testing this API. So let's go ahead, let's clear my previous history here on what I was previously doing with Postman. This is going to be a post request, HTTP, localhost 3000, person. We're going to specify a body. It's going to have a JSON type. It's going to have a first name of Nick and a last name of our boy. I'm going to send it. We got a cast value, which is good. We could specify a different kind of return value if we wanted to, but a cast means that we were successful. So if we go into Couchbase, we look at this document that is now saved. It has a person type and it has a timestamp of when we created it, which is exactly what we'd expect. So far, so good. Now, the next thing we want to do is we probably want to create something for addresses. So to save us some time, let's be a little lazy here. Let's copy this endpoint, not the connection, just the route. Let's paste it. Let's rename it to address. We're going to be expecting a city and a state, a type. Let's not have a. Well, we could leave a timestamp in there, but the type is going to be address. We're going to follow the same steps. We're going to save it and return a cast value again. So let's go ahead and try it. Let's go ahead and go to Postman. Let's go ahead and hit our address endpoint. City, state. This is going to be Tracy, California. I'm going to hit send. It returned a cast, and it appeared in the same example bucket, but this time around the document has type address, which is good. And we're going to be using this information when it comes to querying. So the next step is, well, what if I want to associate a certain address to a certain person? So I could, in theory, store the address information directly in the person document. I could do that. But we actually want to take full control of Couchbase and do something really cool, actually. So first of all, we're going to create a subdocument operation. So we're going to be working with part of a document, And what we're going to be doing is we're going to be inserting the ID, so the ID of the address. So this is the address ID. We're going to be inserting it into an array inside of the person document. And then later we're going to query for it doing some kind of join operation. So let's go to our code. Let's go ahead and create a new endpoint. We're going to copy and paste. Saves me from having to do a lot of typing here. This endpoint is going to be a put because we're editing a document. This one is going to be, let's say, person/address. And what we're going to do is we're going to be expecting an ID. This ID is going to be a string. We don't want to worry about any other data that comes into our payload. We're also saying that we want to match this to a particular person. So inside of our URL route parameters, we're going to have another ID. But that ID is the person ID, whereas the ID inside of payload is going to represent our address ID. And you can name these whatever you want. You know what, we should probably do that just to avoid confusion. Person ID, address ID. So inside of our handler, we can actually edit some code here. So let's go ahead and strip this out. We don't need that anymore. We're going to be doing something else. We're going to say bucket.mutateIn. We're going to say request.params dot person ID. We're going to say 0 on the cast, 0 on the expiration. And we're going to say array append. And I'm going to explain in just 1 second why we're doing what we're doing. So we're going to say array append, and we're going to append it into a addresses property. And we're going to insert, we're going to say request.payload.address ID, and we're going to say true. And we're going to say execute. And believe me, I'm going to come back and we're going to circle back and see what everything's doing. All right, so why are we doing this? So by working with subdocument operations in Couchbase, we're saying we don't want to work with the entire document because the entire document can actually be quite large. So for example, maybe we have a 20 megabyte document. Instead of having to first download that entire document, make our changes, and then post it back up, we can work with a very small bit, which makes things very fast. So the small bit that we're saying is we want to insert items into an array for a particular document. And we're saying that true right here is we're saying if this array value, this property doesn't exist already, let's go ahead and create it and then insert it. Otherwise, we're just going to be appending to the array. So what we're saying is we're saying if error, and we're essentially saying everything that we've done thus far. So I'm actually just going to copy and paste. So I'm copying and pasting the error, and I'm copying and pasting the result. So let's go ahead and give it a try. So we'll go to Postman. But actually, before we go to Postman, I don't know the IDs. So let's go ahead. We're going to copy this address ID. Let's go ahead and go to the address here. So it's person/address address ID. I don't know the person ID yet, so let's go ahead and copy and paste that. We're gonna create an endpoint that'll get us that information. But for now, let's just copy and paste it in, and let's go ahead and send it and see what happens. 404 error not found. So person address, is that what I called it? No, it was actually a put request. So let's try that again. So it worked this time. It did our subdoc operation. It returned a lot of information that we don't really care about in this circumstance. Again, we could always specifically define what will be returned rather than whatever that result was. But for this scenario, it's fine. So let's go ahead and refresh the screen. Now we have a property which is an array of addresses with that ID. So now let's focus on actually querying some useful information in a powerful fashion. So if we go to Atom again, our editor, let's go ahead and create another endpoint here. So I'm just going to create it somewhere in the middle here. Let's go ahead and say server.route. This time it's going to be method, and we're going to say the method is going to be get. The path is going to be person. The handler is going to be the same that we've seen, request, response. And instead of the path, we're going to say people for plural, and we're going to say that because we want to return all people in our database that have the person type. So what we're going to say is we're going to do a query here. So we're going to say var statement equals select, and we're going to say star from example where type equals person. And we're actually going to say example dot star. So it should return all documents where the type property equals person. So we're going to say var query equals nickel query dot from string. We're going to say statement, and then we're going to say bucket dot query, and then error result. And like with the previous endpoints, we can just copy and paste what happens next. So let's copy and paste. Let's go ahead and run our example here. We're going to go do a GET request. We're going to go to the people endpoint. We're going to hit send. And it returned that one record. So we only had one record in our database. Let's go ahead and add another record to our database just for safekeeping purposes, for sanity. For the person, I'm going to say Maria Raboy, send. So if I go back to that GET endpoint, I have two records, one of which doesn't have any address information. However, that address ID isn't particularly useful to us. So let's go ahead and kick it up a notch here. Let's go ahead and expand that into actual useful information. So let's create a more powerful query. So I'm going to say, instead of saying example, just that one document type, let's go ahead and do a subquery. So we're going to say select, and we're going to say let's call it address.star from example, because we only have one bucket, but we're going to alias it as address. And let's go ahead and alias this outer query example as person. So let's change the example part to person. Let's go ahead and change person.type. And we're going to say use keys. And we're going to say person.addresses. So in theory, what this is going to do is it's going to take all of the keys from a particular person.addresses array and do a subquery and kind of add them in. And we're going to say this is going to be as addresses. And instead of saying person.star, we're going to say person.firstname, person.lastname, and we're also going to include the document ID. So meta person.id. Because we didn't actually store the ID in the document itself, we have to look at the meta information about the document. So we're going to hit save. Let's go ahead and try to run it. Send. So this time around it looks a little different, right? So this time around, instead of an ID for address, our subquery is actually getting that address object and placing it in. And it's including our first name, ID, and last name. And of course, the Maria document didn't have any addresses, so that's just an empty array. So it's much more useful. We actually did a subquery, which would have been particularly hard without any kind of query syntax like nickel in your NoSQL database. So the next step, well, maybe we want to add another endpoint. So let's say we want to add an endpoint for addresses, a simple endpoint. So we're going to copy and paste our GET endpoint. We're going to call this addresses, plural. This is actually a very simple query. Let's go ahead and just wipe it out. Easier to type that way. Select meta.id, and you'll see why I'm not adding anything into the parentheses there. We're saying example.star from example where type equals address. So I didn't alias it, so I don't need to add anything inside the meta. It just already knows that I'm looking for the only ID available. and I'm saying that this is looking for address documents. I could have aliased it if I wanted to, but I didn't have to in this circumstance. So if I save it, and I go back to Postman, and I go to addresses, and I hit send, it found that one address. So let's kind of use another scenario here. What if we wanted to use a join? Let's say we wanted to use a scenario where we wanted to find all people that have a certain address. Rather than saying find all addresses for a particular person, let's say find all people who have a particular address. So it's going to be a little different, but our query is going to be very similar to what we've already seen. So let's go to, let's try the following. Let's create an endpoint. This is going to be get endpoint. Let's go ahead and say, I don't know, we'll just paste it below here. This one will be people. We'll say people by address, or let's say address people, and we're expecting an address ID. Keep it simple that way. So we provide an address ID, and we want to return all people. So let's go ahead and erase this query here. And this is where it might be useful to go into the query editor of Couchbase before we actually start typing it into our Node.js. But let's go to the dashboard here. Let's go to our query editor. And let's go ahead and say, first of all, select star from example. We know that this is a valid address, so we're going to copy this key for safekeeping here. But we're going to say select. Let's go ahead and say star for now. We'll come back to it from. Let's actually drop to a new line from example as. Let's go ahead and call it address. Join person. Let's say join person. No, join example as person. Let's say on keys. And let's go ahead and say, I actually did it a little backwards. So let's revisit this. So let's, instead of address, let's call this person. Let's call this address again. So similar formula to what we just did. On keys person dot addresses, and we're going to expand upon this a little differently because we did a subquery before. Let's do a join operation where meta address dot ID equals, and then that's going to be our address ID. So what we had just seen that we had copied here. So if we run this, we do want to change the asterisk a little bit. We want to say meta person.id. Let's go ahead and also say person.first name, person.last name, and hit execute. So it only returned one because that address is only associated to one person, which is exactly as it should be. Let's go ahead and add another person. Let's go ahead and go back to our API here. Let's go ahead and say we want to add a person. Let's say post request. The body is going to be Melissa Prince. Let's go ahead and send it. Let's go ahead and add a new address. Let's go ahead and say Los Angeles. Send it. Perfect. Let's go ahead and look at our documents. We're gonna go back a bit. Buckets, documents. We're gonna find both of that information. We're gonna look for address. Let's look for address. So address is this ID. Let's copy it, and you know we could actually just use the endpoints for that stuff. Let's go use. First of all, let's query for person. So that way we can get the Melissa ID right here. But we're going to create a new endpoint. So we're going to do get. We're going to do, what did we call it? We called it, actually we don't have it yet. We want to just go back to our query. So let's go back to our query here. We have a new address. Shouldn't come up with any results because we didn't associate it to anyone. Let's go ahead and associate it to Melissa. That's what I was looking for all this time. So we have a post request for person address. The address is that one. The person ID, let's go back. I know I'm going back and forth here. I confused myself a little bit, which is all right. We want to find the Melissa document. Copy this. Oh, wrong window. Paste this in. Send it. If I go back to query my people, get people. So now Melissa has a Los Angeles address. I have a Tracy address, and Maria still has no address, which is fine. We go back to our query editor. We run our query here. The Melissa document comes back. I'll go back in time for my history. Only my document comes up. So that's what it should be. So let's translate this into Node code here. So I copied the query, going back into Adam here. I'm going into my statement on line 80. I'm pasting this in. We're going to clean it up so that way Node doesn't yell at us here. Get this all on one line. You can always format it however you want. Instead of having a hard-coded address ID, though, we're going to do $. Let's go ahead and say $address ID. We're going to use a parameterized query. So if we drop down to line 82, we can add our parameters. So address ID without the $, is going to equal request.params.address ID, and save it. So we just did a lot of craziness here. I'll review it in just a second, but let's save it. Let's try to run it. Address/people, and then we want address ID. Let's go ahead and copy and paste an address ID into our postman. All right, so address person address ID, send it. 404 not found. Did I just flip it again? Address people, not person. So address people. Run it. It looks like it worked out correctly. So you just saw how to do a join. I know I did a lot of back and forth here, but the join did work. I think that's all of the endpoints that we should probably create for now. Let's just reiterate what we've learned here, because it was quite a bit. First of all, we did set up Couchbase a little bit. Couchbase was already installed, but we did create a bucket. We created a user account, so a role-based access control, and we created a primary index on our server for our bucket. We set up our connection information for Hapi framework for Node, and we set up a few endpoints. So the first endpoint was a post endpoint for people. So it had two required fields, last name and first name, and then it had two fields that were generated by the server, which was the type and the timestamp. We inserted it and returned the result, which was just a cast value. For the get endpoint for people, if we wanted to get all of our people, we created this one very complex query. So it's actually a query with a subquery in it, but we returned the first name, last name, and address information. Scrolling down a little bit, we do have a simple query for querying all addresses based on the type property. And then another complex query, but this time it uses a join. So all of our document does exist in the same bucket, but we were able to join between documents in that same bucket. So we do have a lot of endpoints here, so a lot of stuff, including this subdocument operation. This is just some of many features that Couchbase has, and very, very useful stuff, very not so difficult stuff that can be included in your RESTful API that you develop with Node and Hapi framework.